Welcome back to C++ with Miyoshi. I just wanted to talk to you today a little bit about random numbers. I want to talk to you about integer random numbers. And I stayed in my Batman costume simply because I want to remind that, hey, remember that flipping the dice is one of the purest forms or one of the most interesting random numbers you can get. Now, if you recall, random numbers aren't really random on a computer, but instead they're a list of random numbers generated by some algorithm. And they're depending on the algorithm, they are either more or less like true random numbers that you would get by rolling a die or tossing a coin or those kind of things. So anyway, we get these random numbers and they are always between 0 and this thing called randmax. Randmax, RAND_MAX, all caps. So that is our list. We have a list of random numbers and that we choose from, and the algorithm chooses the random numbers for us. Now, again, if it was just that list of random numbers in some arbitrary order, and then we just pick a number and then go down that list, there would be that wouldn't be a very good random number generator. You could actually start to choose, or you could start to figure out after many iterations what that random number sequence was. So, but still, you can still think of those random numbers as a list of random numbers. It's just infinitely long. So here is some code, and I will kind of reveal it a little bit at a time, but when you do random numbers, you need to make sure you include time.h. That can give you, oops, I forgot to put it up there, but that gives you the ability to seed your random number very nicely with this srand unsigned time no. Oops. And what that does is it seeds the random number generator with with the time of the computer, and so that gives you a different one every time you run that. That gives you a different random number sequence every time you run the program. If you want the same random number sequence, again, you want to go ahead and use srand with some number that's always constant. So here's a little code, and all I'm going to do is I got int rn is rand. Now that's going to give me numbers between some number. It's going to give me one number between 0 and this magical number randmax. Now it's exclusive of randmax when we do this, so we do just 0, or it could be anywhere between 0 and randmax, not including randmax. So every time we ran this piece of code, it would give us some random number. Now, that's not really interesting, but what about that coin toss? If we have that coin toss, where's my coin? Every time I toss a coin, it's going to give me either heads or tails, right? Well, this here, rn is assigned the value rand modulus 2. That gives me a number either 0 or 1. So again, it's exclusive of the 2. Everything 0 to exclusive of the 2, which means 0 or 1. That's my coin toss, 0 or 1, 0 or 1, 0 or 1. It's going to give me one of those two. And again, hopefully it appears that my random number that I get is not dependent on the last random number I got, or the random number 2 ago, or the random number 3 ago. That's not exactly true, but that's what we want it to appear like. All right, now let's say we want a different random number. Let's say we want to do a dice. Well, a die gets numbers between 1 and 6. Well, if we look at the right side of this, we can think, hey, if I do rand modulus 7, that will make sure that I get a 6. That's all that will go to, right? So if I do rn is assigned the value rand modulus 7, that will give me numbers between 0 and 6, inclusive of 6, exclusive of the 7. Well, that's not quite what a dice does, is it? Well, if I do this, if I just put a +1 there, that would give me the 1, because what happens is when you look at random numbers, you can think of them as, you can think of it as the range. So if I think of this as the range 0 to 1, and I think of this as the range 0 to 6, whatever I do to the bottom number, I can do the top number, and that's how I can kind of determine what the random number is. So if I decide I want to add to it, well, if I add 1 to it, then that's going to give me the numbers 1 through 7, inclusive of the 7 this time. That's not really what a dice does, is it? So the other thing you do is if I decide I want to multiply by it, or I want to, well, take the modulus. When I think about the modulus, that's my range. So if I want to really get a die, I'm going to do Rn is assigned the value 1, which is my minimum number, added to it. And then I do plus Rn modulus 6, because I don't want the numbers, I know that the modulus 7 gives me the numbers 0 through 6, but if I add 1 to it, that takes me beyond the range, like I just showed here. So that I wanted to do modulus 6. This gives me the throw of a die. Well, that's pretty cool. Let's make it a little more general though, okay? So if I think about this, Rn is assigned the value min plus Rn modulus range, where range is an integer of how big we want, how many numbers we have between our two numbers, and min is our minimum. Okay? Well, that's a pretty good formula, but I even went a little bit farther, and I decided let's do int min, int max, and then whether I assign those here, or if I have the user assign them, or whatever I want to do, however I want to assign them. If I want to assign them more than once, I could change them and run this again. I have this formula here. Rn is assigned the value min plus Rn modulus parentheses max minus min plus 1. Well, the max is this max over here. The min is that same min. And again, whether I put that in there with the code, or I put that in there, the user puts it in there in the code, doesn't really matter. However I decide to assign that. And then I add the plus 1. This will give me my range. Max minus min plus 1. The reason I have the plus 1 in there is I want to make sure that this is inclusive. This is inclusive of the max. So Rn is assigned the value min plus Rn modulus max minus min plus 1, and that's all in parentheses. That will give me inclusive of my max. Okay? If I do Rn is assigned the value min plus Rn modulus max minus min, that will give me that range between min and max, but it won't include the max. So that'll give me all the any integer between min and max, exclusive of the max. So this is kind of a nice way to think about random numbers, especially integer random numbers. Well, this is just integer random numbers. And remember, it's just going to select from my list of random numbers to put in there where rand is. Everywhere rand is, it's just going to be selecting from that list over there. And then it's going to do these things to get our different types of random numbers. A coin toss, rand modulus 2. A die toss, 1 plus rand modulus 6. Or any random values between our min and a max, including the max, with this min plus rand modulus max minus min plus 1 in parentheses there, or a range of numbers between the min and the max exclusive of the max. That would be min plus rand modulus max minus min. So integer random numbers, they are very useful. You're going to use them a lot in programming, not just to show dice throw, but for many other things. And remember one other important thing: if you want to have the same random number sequence all the time, just do srand some number there in parentheses, and remember you only do that ever once in a program. Or if you want the same, now if you want different sequence of numbers all the time, do srand every time you run the program. Do srand open parentheses unsigned time null. This, and again, you only want to run this one time in your main, even if you have many functions in your program. Which you may or may not know what functions are yet, but you only want to run this ever once in a program, and this would be inside my main, whereas this is not. So anyway, random numbers, random integers, that's how we create them. That's how we figure out how we want to have them between two numbers. So thanks for tuning in, thinking about random numbers. Thanks for tuning in with thanks for tuning in with me for C++ with Miyoshi. We'll see you next time.